Okay, so define vertical asymptotes. Set the denominator equals 0 and solve. So for vertical asymptotes, you set the denominator equals 0 and solve. So here we have x squared minus x. We set it equals 0. To solve this, we factor out an x. So it's x times x minus 1 equals 0. So x equals 0 and x equals 1. How many asymptotes do I have? 2 asymptotes. The function has 2 asymptotes. The leftmost one is x equals 0. The rightmost one is x equals 1. Okay. Horizontal asymptotes are a little more complicated. So when the powers are equal on the top, like x squared over x squared, like ax squared over bx squared, if the powers are the same, if the highest powers, I should say, if the highest powers are the same, then use the coefficients of the highest powers. Okay, so in this case, the horizontal asymptote would be y equals a over b. Okay, so if your powers are the same, if you have a 4x squared over 2x squared, then your horizontal asymptote would be x or y equals 4 over 2 or y equals 2. If the higher power is on the bottom, if the higher power is in the denominator, then it's going to be the x-axis. Okay, y equals 0 is going to be your horizontal asymptote if the higher power is in the denominator. If the higher power is in the numerator, then there's no horizontal asymptote. Then we're not going to have a horizontal asymptote. Okay, so you got to remember those 3 things. Okay, if the powers are the same, use the coefficients. If the higher power is in the denominator, the horizontal asymptote is y equals 0, the x-axis. If the higher power is in the numerator, then we don't have a horizontal asymptote. We might have a slant asymptote, but we don't have a horizontal asymptote. All right, I didn't mean to do that. Okay. So the problem was f of x equals 4x minus 1 over x squared minus x. All right. Your numerator has a first degree equation. Your denominator has a second degree equation. So your power in your denominator is higher than the power in the numerator. So do we have a horizontal asymptote? Yes. And it is at y equals 0. Okay, y equals 0. So what's going on here is we have a vertical asymptote at x equals 0, a vertical asymptote at x equals 1, and a horizontal asymptote at y equals 0. So what points do we have? Well, I'm guessing this is out like this. This is out like this. It's what's happening in between is what I don't know. So if I put like a 1/2 into here, 4 times 1/2 is 2, 2 minus 1 is 1. So when I put in 1/2, the numerator is 1. I put in 1/2, 1/2 squared is 1/4, minus 1/2 is a negative 1/4. So it's 1 over negative 1/4 or negative 4. So at 1/2, we're at negative 4 down here somewhere. And what I'm thinking is it's going to go like this and like this. I'm not sure, but I think that's what happens. To check, I'm going to grab my graphing calculator again. I'm going to go y equals on, y equals, and my numerator is going to be 4x minus 1. My denominator is going to be x squared minus x. If I graph it, it's going down like that. And it's really tough to see here. So if I trace to 0.1, I'm up there a little bit. 0.2, I'm down a little further. 0.3, I'm below the x-axis. 0.4, I'm keep going down. So it's coming down like this. Okay, so knowing what the graph looks like now, as I'm going towards 0 from the left, looks like I'm going towards negative infinity. As I'm going towards 0 from the right, looks like I'm going up to infinity. As I'm going towards 1 from the left, I'm going down towards negative infinity. As I'm going towards 1 from the right, I'm going up to infinity. As I'm going towards negative infinity, as I'm going this way forever, my horizontal asymptote is at 0, so I'm going towards 0. As I'm going to the right forever, I'm also going towards 0. So the vertical asymptotes deal with this. These are my horizontal asymptotes. Okay, that's how I'm dealing with everything. Okay, let's do the same type of thing to this one. Okay, so vertical asymptotes. How do I factor the denominator? X and x plus and minus. What and what? Make 30. Better, one apart. So 5 and 6. What goes with the minus sign? 6 goes with the minus, 5 goes with the plus. So x plus 5 equals 0, x minus 6 equals 0, x equals negative 5, and x equals a positive 6. So there are two, it's asking horizontal asymptotes first. Okay, the higher power is in the denominator, so I have one horizontal asymptote. It's going to be x equals 0. Vertical asymptotes, I'm going to have two. The left one is at x equals negative 5, and the right one is at x equals 6. X-intercepts. To find an x-intercept, set the numerator equal to 0. So if we set the numerator equal to 0, where's our x-intercept at? X minus 1 equals 0, so x equals 1. Type an integer or fraction? Integer, just 1. To find a y-intercept, plug 0 in for x. So if you want to find a y-intercept on any equation, plug 0 in for x. So you get negative 1 in the numerator, negative 30 in the denominator. Negative 1 over negative 30 is a positive 1/30. So what does it look like? Well, we have asymptotes at negative 5 and a positive 6. And I have a y-intercept at 1/30, just barely above 1, and an x-intercept at 1. So it's going to cross at 1, and then I'm at negative 5 and a positive 6. I would say it looks like B. You can always check with your graphing calculator to be sure. All right, for this one, do I have any vertical asymptotes? At a negative 1, x equals negative 1. X-intercepts, you set the numerator equals 0. So your x-intercepts are 1 and 3. To find your y-intercepts, put 0 in for everything. 3 over 1 is 3. So this is an example of a slant asymptote problem, okay, where we have a higher power in the numerator than the denominator. So we have a vertical asymptote at x equals negative 1, so it's not this one. It's one of these two. I have an x-intercepts at 1 and 3, so it crosses at 1 and 3. It's really hard to tell here on this. And a y-intercept at 3. Again, really hard to tell. I'm kind of thinking it's B. I'd have to zoom in to see which ones work. And then on this one, what happens when you have a number on the outside? It moves it up or down. Okay? So if you have a k out here, plus 3 over x minus h, the k slides up or down. The k makes it slide up or down. The h shifts it right or left. And this is your multiplier, which stretches it up and down a little bit. So this one looks like it has a vertical asymptote at 3. Okay, this one has a vertical asymptote at 3, and that's the only one. So this one goes with this one. This one looks like it has a vertical asymptote at negative 2. This has a vertical asymptote at negative 2, so does this one. However, this one has a horizontal asymptote of 0. This one would have a horizontal asymptote of 2 because we're shifting it up 2. So this one goes to here. This one, that's vertical. Actually, this one has a vertical asymptote of 2 as well. Oh, yeah. Okay. So this would be x minus 2. All right. So negative 2, negative 2. So there. Yeah, this one's wrong. I was looking at the wrong one. Here is a negative 2. There we go. There and there. Negative 2, negative 2. This one has a vertical asymptote of 1. And this one has a vertical asymptote of 5. And this one has a vertical asymptote of 2. Okay? So you'll be doing some matching on these. All right. Use a graphing calculator, figure out that what numbers should be excluded from the domain. Well, where are the vertical asymptotes? Well, x times x plus 5 equals 0. So it's 0 and negative 5. Here, x squared over x plus 4. Okay, the higher power is on the top. So it has no horizontal asymptote. but the vertical asymptote is at x equals -4. Now, you'd have to look at a graphing calculator to see if it has a slant asymptote, because it could possibly have a slant asymptote. Okay, but it does have a vertical asymptote. It does not have a horizontal asymptote. So it must be C. Okay, so not too many problems on this one. So let's get our 2 assignments done today. So we're squared away, so I can get them in the grade book. I got to catch up grades here soon. Get all your grades in, because these are the last 2 grades of the quarter right here, these homework grades. So if you have any missings, you need to get them done here, hopefully tomorrow, study hall time. Okay, all right, there you go.